fellow students and my good friends. I hope you're okay and you're doing well. In my previous video, I did post paper 2 questions. And what I'm going to do in this upload or this video is to post the marking scheme for the very paper I did post previously. What I am expecting is that my student, you interacted with the paper, you attempted the questions, and you're very eager to get the marking scheme and even the discussion. So what I'll urge you to do is to go step by step. You can stop the video, you can interact with it, and finally you can make your comments there. Then maybe I can respond to them later. Remember also what I requested before. You take a short clip of yourself and tell me what is your take on this subject, chemistry. To my other friends, we talked of a program to touch a life. So watch the video to the end because I will post some details of a student that we want to start helping. So we said we are going to get that opportunity to touch a life. And that is for my students. Kindly go through the marking scheme of these people. Okay, with question number 1, Roman 1, the question was asking you to name the process through which the components in crude oil are separated. The answer there is fractional distillation. With Roman 2, you're supposed to name 2 physical properties that makes it possible for the above components, that is the components in crude oil, to be separated. This component must be miscible, then they must have close but different boiling point. Actually, we usually say the boiling point range for fractional distillation process must be less than 40 degrees Celsius. With part B, you're given that hexane, that's an alkane, can undergo a given process and then gives 2 compounds. That process automatically is cracking, be it thermal cracking or catalytic cracking. So you're given that one of the component is C3H8, that is a propane. So with that, if you can consider the number of carbon atoms, the other compound that we know given should have 3 carbons and then should have 6 hydrogen. And that product is, we call it propene. Propene now with E. With this one, if you consider what the question is asking, you just need to give the formula C3H6, the formula of propene. Then now you're supposed to go ahead and discuss or describe a chemical test that can be used to distinguish between the 2 products. That is an alkene and an alkane. So with this, you need to use any appropriate method that can be used to distinguish between an alkene and an alkane. You can use bromine water. With bromine water, as I have highlighted with the red color there, the bromine water with the first one, if it is a propane, the bromine water will not be decolorized, it will remain yellow. If it is with a propene, then the bromine water will change its color from yellow, of course, to colorless. You can use acidified potassium manganate 7. With the propane, that's an alkane, the potassium manganate 7 remains purple. If it is with an alkene, that's a propene, now it is decolorized. With the potassium dichromate 6, that one now will change the color from, if you are working with an alkene, the second one, it will change from orange to green. But with the alkane, the first one, C3H8, the orange color of the dichromate will remain. Remember, if we are talking about physical tests, we can also do the burning. If we do the burning with alkanes, that is the C3H8, it will burn with a blue flame. If it is with alkene, it will burn with a luminous flame, that's a yellow flame. Part C of this question, you're given that setup for the preparation of ethene. And as we had discussed in the question, you can see how the setup is. Part 1, you're supposed to name the substance T. Substance T is a potassium hydroxide solution. Remember, that is sodium hydroxide solution. You can also use potassium hydroxide solution. The function of that one, if they may ask, is to absorb carbon oxide that may be generated when ethanol undergo combustion, or even sulfur oxide that may come from the concentrated sulfuric acid. With part 2, why is it possible to collect the gas through this method, ethene? It is because the gas is insoluble in water. This method is called overwater method for gases that are insoluble in water or slightly soluble in water. With part D, you are supposed to name the polymer that is formed when ethene undergoes polymerization. This one we call it polyethene, or we can call it polyethene. Some people also, in some cases, the old name, we can call it polyethylene. Disadvantages of polyethylene or polyethylene, basically as we call them, they are non-biodegradable. They pollute the environment because they will take longer time to decompose, or rather, they have a long lifespan. Again, if you burn them, they give some harmful gases. If you burn some polythenes. Good. Going on now to question number 2. Question number 2, you're supposed to name a method that can be used to differentiate or to separate iron 3 chloride from sodium chloride. One property with separation of mixture, the physical properties of the component is what guides us. So with this one, iron 3 chloride do sublime, but sodium chloride does not sublime. So the method, the most appropriate method we can use is sublimation. You heat the mixture, then the iron 3 chloride will sublime, while sodium chloride will not. With part B, remember the table you're given. You're given the properties of 3 components: sunflower, the flour, the common table salt, then solid red dye, the solubility in water and ethanol as it was given. So there is a student here who intended to separate the 3 components and was provided with ethanol. So how can we describe, or how can we step by step separate the 3 components? The first thing you can do is to add ethanol. Why do you bring in ethanol? Because ethanol, once you bring in ethanol, it will dissolve the red dye. Selectively, it will dissolve the red dye. And once you do that, you filter to obtain the red dye as the residue. Then a mixture of ethanol solution and what we call that, the mixture of ethanol and sunflower, because now there will be as a residue, they'll come out as a residue. The red dye will be in the solution. Then when you come to the next step, you evaporate the filtrate to obtain the red dye. That is the first component that you have already obtained. The next, now bring in the water to the residue you have. Why do we bring in the water? Because the common table salt will dissolve, but the sunflower flour will not dissolve. So then you go ahead and filter to obtain the sunflower as the residue, flour as the residue, and of course go ahead, because now in the solution there will be sodium chloride, this common salt. You evaporate to obtain it as the final component there. That is the step by step. Remember, with the separation of mixture, the steps are very key. If you miss a step, then it's not possible to separate the mixtures. Then going on to the question having periodic table, it's supposed to explain why the oxidizing power of W and X differ, how they compare. These are halogens. And if we consider halogens very well, they are oxidizing agent. They are species that can easily gain electron, 1 electron very easily. With W, it has a small atomic radius. And with a small atomic radius, it means the element is more electronegative. That means it can easily gain an electron. The atom is not very big, and that means the effective force of attraction to an incoming electron is very high. The nucleus is not so much shielded inside. So with part 2, how the melting point of R and T will compare. These are two. Anytime you ask of the physical properties like the melting point, you go directly to the type of structure. That is structure and bonding. So with this one, metal, the R is a metal, while T is a non-metal. That is, at the back of your head, you should know R is lithium, while the other one, that is T, is oxygen. Yes, that is oxygen. So the first thing you state is R has a higher melting point than T. The reason being, R has a giant metallic structure with very strong metallic bonds that requires a lot of heat to break, while T is molecular, and the molecular substances do have weak van der Waals forces between them, which requires less energy to break. With this one, we go to part 3. We give the formula for the compound formed between W and Z. W at the back of your mind, you should know this is magnesium. Well, that's Z is magnesium. W is chlorine. So whether you use directly the letters as they are, that is W has a valence of 1, chlorine that is, Z has a valency of 2. Then of course you combine. Remember to start with Z because the metal comes before the non-metal. So the formula will be as it's given, ZW2. Otherwise, if you identify them and go ahead and write the formula, to be okay. Magnesium chloride with a 2 there. Going ahead to part 4, you're supposed to identify the position of K, group 5, period 2. As it is indicated there, it is immediately before element T. That is electron configuration 2,5. We do a dot and cross diagram for K and hydrogen. Every time, though you're supposed to use the letters, you should know what exactly the letter represents. This nitrogen, so nitrogen and hydrogen, that is the structure of ammonia. With ammonia, it is the K element, that is nitrogen, that is bonded to 3 hydrogen ion atoms covalently. And remember, there is a pair of electrons that remain unbonded. That is it, the structure as it is, and it is well illustrated. You give one element that can be used in weather balloons, that is helium. It's very light and it's an inert. One element that can be used to make cooking pot, that is N. Remember, helium is Q. Then N is aluminium, a metal that is a good conductor of heat. Therefore, it can be used to make the pots. We go on to question number 3. This is a question on contact process, part of the contact process. And part A, you are supposed to describe how oxygen can be obtained from the air. So you simply need to give the 6 steps of fractional distillation of liquefied air. The first thing is to remove the dust through dust filters, that is dust precipitation, then pass the residue air through sodium hydroxide or potassium hydroxide that will remove carbon dioxide. Then cool the remaining air to negative 25 degrees Celsius. That removes water in form of ice. Then we go ahead, compress and allow the remaining air to expand. You compress, repeatedly to a pressure of about 200 atmosphere. With this, the air will automatically liquefies and the temperature drops to negative 200 degrees Celsius. Then do fractional distillation. The 3 components remaining, that's nitrogen, argon, and oxygen, will distill out at their respective temperatures or boiling points. With this, we only need to state that oxygen will distill at a negative 183 degrees Celsius. That's how you obtain it. You name substance substance A in this case. From the absorption chamber, we have oleum. Oleum is diluted using water, and once you do that, you get concentrated sulfuric acid. So the substance A is concentrated sulfuric 6 acid. If I was to write the equation of what is happening in the absorption chamber, it is basically the concentrated sulfuric acid that is reacting with sulfur 6 oxide to form oleum. The equation is there. With the part C, vanadium 5 oxide is the common catalyst for contact process. Another catalyst that can work very well is platinum. It's platinum. Platinum can work very well. 2 reasons why we prefer vanadium 5 oxide. 1, vanadium 5 oxide is cheap compared to platinum. 2, vanadium 5 oxide is not prone to poisoning. It's not easily poisoned by impurities. It is a bit resistant. With this, we go ahead with part D. The observation that will be made, if you have concentrated sulfuric acid, then you pour it, some few drops onto blue copper 2 sulfate crystals. the crystals will simply change from blue to white. The reason for that, the sulfuric acid, when concentrated, it has very good dehydrating property. So it will dehydrate the blue copper 2 sulfate from blue to white. And that's, by absorbing. Okay, with part E, the question is asking of the property of sulfuric acid, that's concentrated sulfuric 6 acid, that is portrayed when you have sodium chloride mixed with concentrated sulfuric acid. In this case, we say concentrated sulfuric acid is less volatile, and being less volatile, it's able to displace acids of more volatile from their salts. Like sodium chloride, you get hydrochloric, that's hydrogen chloride gas. With that, you're supposed to give 5 uses or 4 uses of sulfuric 6 acid. Can be used in car batteries, can also be used to make some soapless detergents. It can also be used to make phosphate, that's phosphate, not in sulfate, agricultural fertilizers, making of dyes and paints, and even cleaning of metals. Question number 4, what is molar heat of combustion? Molar heat of combustion, it is the amount of heat that will be generated when 1 mole of a substance completely burns in oxygen. Hess's law just is that the total energy change for a reaction, it's the same regardless of the route that the reaction will take under the same conditions of temperature and pressure. With question part C, remember this one had some correction on the question because you're given the enthalpy change of combustion of graphite, that's of carbon. You're given the enthalpy change of combustion of hydrogen and the enthalpy change of formation of propane. So if you to write the equation for the formation of propane, it is 3 carbon atoms bonding with 4 moles of hydrogen gas to give you now the propane, CH, and that is C3H8 as it is given there. Now with this one, that's part 2. Now you are to use Hess's law. You try to draw the energy cycle diagram to show the 2 routes for maybe the formation of propane. You can have the 3 moles of carbon, 4 moles of hydrogen bonding together directly to form propane, and the enthalpy change has been given, the negative 104 kilojoules there. Remember, you can use the other route, whereby you can first of all burn carbon to get carbon dioxide, 3 moles of carbon burnt. 4 moles of hydrogen can also be burned to get 4 moles of water. Then on the other side, as you can see on your right hand side, you can have now the combustion of propane to get the same products, that is 3 moles of carbon dioxide and 4 moles of water. So if you look at that, it's like a cycle. It is 2 routes that are heading towards the same thing. So with this one, you can go ahead and calculate the missing enthalpy change. Like we are missing the enthalpy change of combustion of propane. So that one you can obtain it by following the first route. You can follow the route from the 3 carbon atoms, 4 hydrogen molecules towards the propane, then all the way to where it is burned. So if you have that, the vector way, you combine and try to follow what I have done. The enthalpy change of combustion of propane will be given by the enthalpy, the negative enthalpy change of formation of propane, because you are going against that arrow, added to 3 enthalpy change of combustion of carbon plus 4 enthalpy change of combustion of hydrogen. If you work out that, you get quite an exothermic process there, giving you 2219 kilojoules per mole of propane. The reaction there is exothermic, therefore it will be negative there to show it's exothermic. Other than enthalpy of combustion that help you maybe to calculate the heating value, other factors to consider when you're choosing a fuel: the cost of the fuel, availability, cost of transportation, environmental effect of the fuel, is to use the fuel among others. Going ahead, you're given that you have 2 strong acids, HCl and nitric 5 acid. If you do enthalpy of neutralization using these 2 acids, the enthalpy change will be negative 57.2 kilojoules per mole. But in case you're using ethanoic acid, that enthalpy change drops to 55.2. You're supposed to explain what exactly is happening. So with these, the two acids are very strong, so they dissociate completely in water. But with ethanoic acid, it's a weak acid that will partially dissociate in water or ionize in water. For that reason, if you're using ethanoic acid for this process, first of all, some of the energy will be used back into the process to help ethanoic acid molecules to ionize. So for that reason, the overall heat change for neutralization process will be less when you're using ethanoic acid, because some of the energy have been absorbed ionizing the molecules. With that, we go to question number 5. This is a question on solubility. And the first question is you define the term saturated solution. I think the concept given there is not right. But you can see the correction here. That we were defining not solubility because the definition given is for solubility, but we were defining a saturated solution. And this is a solution that contains the maximum amount of solute it can hold, or the solution can hold, at a given temperature. I think the solubility definition given there is different. Part B, you're given a table and you're given some values on the table, the temperatures and the solubility at the respective temperatures. You are supposed to use this information and plot a graph. That is it. So the graph, as you can see, there it is. You have the scale. If you are choosing a scale, at least your graph should occupy 2/3 of the page. It should be of a good size there. So the marking there, the scale, you get a half a mark. Then the labeling, you must label the two axes, the temperature and give the units. The solubility, that's y-axis, and give the unit. Then plotting the points appropriately, you get 1 mark. And then the curve, that solubility curve as it is, you get the mark. So going on, we are supposed to use the graph and now determine the solubility at 15 degrees Celsius. As you can see in the graph, kindly show at 15, try to interpolate and show how you obtain the solubility. So on the graph, it's well indicated, and the solubility is 25 grams of potassium nitrate in 100 grams of water. Then if you were to start, that's part 2 now, if you were to start with 80 grams in 100 grams of water, and then you warm that mixture to 100, not 100, but to 40, you going back to the graph, you will first of all determine the solubility of potassium nitrate at 40, and that solubility is 61 grams in 100 grams of water. That implies that if you were to add 80 grams, 61.5 grams will be in solution. So the remaining will be 80 subtract the 61.5. You get, that is 18.5. It will be 18.5 grams of the salt will remain undissolved. Then go ahead, you are supposed to calculate the molar concentration of potassium nitrate at 15. Remember from Roman 2 part 1, the solubility of potassium nitrate at 15 is 25 grams in 100 grams of water. So first of all, work out the molar mass of potassium nitrate, and you get is 101. If that is the case, then you can go ahead and get the number of moles in 100 of that solution at 15. That means the 25 grams divided by the molar mass, and you get now the 0.2475 moles. Then if this amount is in 100, then in 1,000, you need to just multiply by 1,000 over 100 or multiply by 10. And you get the molar concentration of this solution is 2.475 molar. Going on to question number 6, and then you're told that carbon dioxide is present in soft drinks. Two roles of carbon dioxide gas. One is to preserve the gas. The carbon dioxide will create an environment not favorable for any microorganism to grow or to survive that will make the drink go bad very fast. So with that, the other use is to improve the taste of the drink. Going ahead to part 2 of the question, then you are supposed to explain the observation that we oftenly observe when you open a soft drink like a soda. Obviously effervescence of a colorless gas do come out, so you need to explain where exactly do we get those, where do they come from. Remember, when carbon monoxide is dissolved in water, it forms the weak carbonic acid. The weak carbonic acid, when again exposed to the air, or when allowed to release out, it dissociates back to carbon monoxide and water. So the fizzing sound, the effervescence you observe, these are just carbon monoxide from the carbonic acid. The formula of carbonic acid, that's part 2, H2CO3, the weak carbonic acid. Going ahead, if I have zinc oxide and I'm obtaining it from zinc nitrate, I'm starting with 5.76 grams of zinc nitrate. The equation is as given: 2 moles of zinc nitrate. When decomposed, that is the process we call thermal decomposition, you get 2 moles of zinc oxide, 4 moles of nitrogen oxide, and 1 mole of oxygen. The equation is well written, should be well balanced, should have the state symbols. If I am to do the calculation, I need to know the volume of gases, total volume of gases that was produced. Remember the two products that are gaseous in gaseous state, nitrogen oxide and oxygen. In total, I have 5 moles. Start by working out the number of moles of zinc nitrate. With this, it will be, that is the 65, 28, and even the 6 times 16. You get 216. Work out the number of moles of zinc nitrate. That will be now the mass given divided by the molar mass. And of course, you get the number of moles as indicated, the mole ratio for all the reactants and the product as it is given. So with that, you can be able to go ahead and get the total number of moles of the gases that were produced. 5 times, of course, half the number of moles of zinc nitrate. Remember, you're just using the mole ratios. Simple mathematics, you get the mole ratios. If you want to get the total volume, it is the number of moles divided by the molar gas volume, 24 dm cubed, and you get 1.596 liters dm cubed. That is with part 6. Part C, now you have the setup there. Inside the combustion tube is zinc oxide. Yep, then carbon 2 oxide is passed over it. Remember, carbon 2 oxide is a good reducing agent. So what exactly it will do is to react with zinc oxide and reduce it to zinc, and itself is converted to carbon oxide. The observation that took place inside the combustion tube, zinc oxide is oftenly yellow when hot. So if you heat it, and of course white when cold, so it will start from the white color, becomes yellow, then eventually it will be gray. Why will this happen? Zinc oxide is white when cold, yellow when hot, because it will just become hot. Then if you go ahead, okay, yellow and hot, and finally, because zinc metal will be formed, now you'll observe the gray substance at the end of the reaction. With the equations taking place in the boiling tube, that is in the boiling tube, I think also there the equation is misquoted. It is the carbon oxide, because it's the carbon oxide that is reacting with the calcium hydroxide, lime water, to give you that will be calcium carbonate, the white precipitate there. And remember, if you proceed this for a long time, then you will have the calcium hydrogen carbonate, a colorless solution being formed. So note that the equation given there is taking place inside the combustion tube, not in the boiling tube, but the correction is given there. Check on the correction. Then on the flame, carbon 2 oxide is combustible, very combustible, and therefore it burns in air, in oxygen, to form carbon oxide. The color of the flame is blue. Going on to question number 7. You're given that flowchart, and what I can advise before you go on to answering the question, first of all, study the flowchart. That is what the question directs. You study the flowchart. And studying this flowchart, you can start from step 1. For example, in step 1, you're adding water, you're doing filtration. Maybe there's nothing much you can say there because you don't know what X contain. The mixture X you don't know. But if you go to step number 2, on your left there is a solid there that is being heated. And when it's heated, there is a solid Q coming out, a gas which forms white precipitate when passed through lime water, calcium hydroxide. So automatically that can give you the first hint that the black solid, most likely it is copper 2 oxide. And later on you'll confirm whether it is copper 2 oxide. But the gas that forms white precipitate with lime water, that must be carbon 4 oxide, most likely. And if that is the case, you proceed now to adding dilute sulfuric 6 acid. And automatically you can now see a blue solution. And that confirms the solid Q was copper 2 oxide that reacted with sulfuric 6 acid to form the blue solution copper 2 sulfate. Going on to step number 4, you're adding aqueous ammonia and you find the deep blue solution. That is another confirmation that copper 2 ions are present because you're getting now the tetraamine copper 2 ions as it is given the deep blue solution. If you go ahead to step number 5, with step number 5, the mixture we had before the blue solution, we are adding magnesium powder. Magnesium powder, magnesium being more reactive than copper, it do displace the copper 2 ions. And copper metal will be formed, that is now the brown deposit, and magnesium sulfate will be formed. So that is a displacement reaction, step number 5. If we go to your right, that is step number 6, where you're adding acidified barium nitrate and then do filtration. Automatically that tells you there is a precipitation reaction taking place because there will be a white solid coming out. That automatically will be barium sulfate. We are going to see how did we conclude that this is barium sulfate. It will take us back all the way to zinc sulfate. But let's first of all talk about the left-hand side where you have the colorless solution. Why do we conclude that this is zinc nitrate? Because you added barium nitrate, there must be a cation coming from solution P, and the cation coming out from solution P can be confirmed with step 7, because when you add aqueous ammonia, to a solution containing metal ions, then there is a white precipitate which dissolves in excess sodium, that is aqueous ammonia. That automatically is zinc 2 ions. If it is zinc 2 ions that were present, it means these zinc 2 ions must have come all the way from the mixture X. So there is a zinc salt. We want to conclude, why can't we say it is zinc carbonate? Zinc carbonate is not soluble. Why not zinc chloride, for example? Why not zinc chloride? Because when you add a barium to a solution with chloride, you don't get the white solid. You don't get a white precipitate. So automatically it was not a chloride. Why not zinc sulfite? Zinc sulfite, because if the barium was acidified, barium nitrate was acidified, the white precipitate, if it was a sulfite, ought to have dissolved. And that is how we conclude that the other salt that is in mixture X is zinc sulfate. We do that deduction there. And the other one is the carbonate. Why carbonate? Copper 2 carbonate. We have followed the first route and we have found that there is a copper particle in the salt that we analyzed before. And because of the colorless gas that forms white precipitate with the calcium hydroxide, we conclude there was a carbonate. So now we can go ahead and answer the questions. The anion present in that is solid Q, that's copper 2 oxide. It is an oxide radical there, or ion, an ion. If I can talk about the two salts present in X, we have seen that it is copper 2 carbonate and the zinc sulfate. The equation taking place in step number 5. step number 5, you can see there that is barium ions combining with the sulfate ions to form barium sulfate. So that's a precipitation reaction, the equation of interest there. We explained the observation at step number 5. Going back to step number 5, that is where now you have the blue solutions, then you add magnesium powder. The observation, as it is indicated, first of all, the blue color of copper 2 sulfate will fade because we are removing the copper 2 ions from solution by they are being displaced by magnesium ions or replaced by magnesium ions. There will be a brown deposit of copper metal because copper 2 ions, again, they are being reduced to copper metal, which is brown. Then if I had to monitor the temperature change with a thermometer, there will be an increase in temperature. The displacement reaction is basically exothermic. The part D of the question, if I want to prepare lead 2 sulfate, starting with the lead 2 oxide, remember lead 2 oxide is insoluble in water. You cannot start reacting or dissolving it in water. So what you need to do is to have an acid like nitric 5 acid. So nitric 5 acid, you add excess of lead 2 oxide. If you do that, then of course it will dissolve. Then you'll stir, make sure it is warm nitric acid to ensure the reaction is fast. Then you filter out the unreacted lead 2 oxide. Remember, the solution you have obtained is lead 2 nitrate. Lead 2 nitrate, now you are ready for a precipitation reaction because lead 2 sulfate is an insoluble salt. With that, we add dilute. You can use any sulfate, soluble sulfate or sulfuric acid. You mix a solution of a sulfate containing sulfate with your filtrate above. And remember now, your filtrate above has lead 2 ions. Then you'll come on to combine it with the sulfate. You get lead 2 sulfate. Then you need to filter it out, rinse with some distilled water, and of course go ahead and dry it using filter papers, or in the sun you can use the oven. Then how can you determine that this is a very pure substance, that is pure lead 2 sulfate? The best way you can do it is heat the salt until it melts. Then monitor the melting point, which will be constant. I know it's a bit challenging because the salt might melt at very high temperatures, but it is still practical. That is it. And that's the end of the paper 2, that is 2.3/2. Of course, anticipate for more. I'll come in with some more papers. And do not forget to tell a friend, subscribe to this channel, write down your comments. As I said before, take a short. Okay, the student that I would like to request all of us to assist is a student in the station I'm teaching. And the student is in Form 3. And she lost her father. That is like 4 months ago. That is October last year, the year 2021. And she has had now issues with the school fees. Being a Form 3 now, and we know the Kenyan system of education, how it is today, the calendar, she will be in Form 4 this year. So with this, the girl need to be sustained in school. She's a disciplined girl and hardworking. That one I can attest. And her name is Teresia. So what we need to do, I'm going to share with you her detail and the details of the school's account number. Then, of course, once you enter the account numbers I've given you through your M-Pesa, you can pay this through your M-Pesa. You're going to enter the information as I've given you, and this will go directly into her account. That is, the payment will be under her name because I've even attached the admission number of the student. And once you do that, you can forward me that message on the WhatsApp number that I have indicated there. And God will bless you. Maybe in my previous or the next video, I will request the girl to just be seen. I will request the girl to allow me bring her to you. And I'm very sure she will be very grateful on that. So that 100 shillings, 200 shillings, 500, 1,000, kindly, if you post it or you send it into the account that I'm sharing with you, it will be to the benefit of this student. And I will know it will add a smile to her face. Thank you so much, and may God bless you. Continue watching the Dr. Sirme chemistry uh,